So I hope that you all watched the online recording because that one is really exhaustive of the content that will be involved in the exam. This lecture is mainly meant to update you on some of the contents that we discussed. So some topics, I want to make some clarifications for some. I want to revise some of them, and I want to give you some more additional information if you're interested. So the first thing that I want to discuss is why we are discussing SQL injection at all and what is the purpose of this lecture. So the reason why I chose to design this lecture from the perspective of the attacker was because typically security lectures come from the perspective of, defenders. Okay, these are the secure practices. This is how you should build your systems. But if you don't know how the attacker will exploit it, of course, you won't know how to build a system that is truly secure. So with that in mind, we started the first part of the lecture with the threat landscape. So we talked about threats that are faced by web applications that particularly involve databases. In the previous quarter in web and database technology, you might remember that we talked about a lot more, and there we were really focused on threats on websites. But here, whatever we talk about, it's always in the context of, let's suppose you have a database at the backend, right? And then there was one slide with a lot of best practices, which, I mean, if you're a developer, you should follow, but if you're not, just a normal user of the internet, you should still follow them because they're nice and they keep you safe. All right, then the second part of the lecture was about SQL injection attacks. We talked about what an SQL injection attack is, and then we talked about various versions of SQL injection. So if you remember, tautology-based attack, union-based attack, and then we looked at very, very briefly on what piggybacked attacks are. And in this lecture, I want to go a little bit more detail on what are when certain attacks would be used. But the reason we talked about those attacks and how to actually do them is so that when we talk about mitigation methods for SQL injection, we are able to think how it wouldn't save us from certain type of attacks. So this is also something that I want to go into more detail today. One comment, so anything on any slide, if you see an extra content star like that, that means it's not part of the exam, but it's still good to know if you're interested, so you can skip that part. I will also upload these slides at the end of the normal slide deck that was already uploaded on Brightspace. So if you're interested in this slide deck, then, well, you will have access to it. Secondly, if you have any questions about other parts of the course, you can still write them on Mattermost, but we will not cover them today. Okay. So let's start by talking about the CIA triad. So confidentiality, integrity, and availability. Now, when we talk about information security in general, there are a lot of concepts, of course, because we have information systems all around us now. And so CIA triad is just one of the many, many frameworks that exist to characterize information security and making sure that, to sort of systemize education and research in this topic. So confidentiality was about whether your information is protected. So an example here would be if a data breach occurs, or if you, if I create an exam and you're able to see it, then the confidentiality is breached. Then integrity is about whether the information is accurate. So for example, if I send a message to my friend John and you're able to intercept the message, and then you change the message, then of course the integrity is violated. And finally, availability is about whether a certain resource is available or accessible to legitimate users. So a typical example of targeting availability is a DOS attack, a denial of service attack. So the reason why we're discussing the CIA triad now is just to give you an idea that there are more advanced versions and more extended versions of the CIA triad, particularly that involves authorization, non-repudiation, and so on. So these are advanced topics and you don't have to worry about them right now. But just remember the basic CIA triad. Okay. Yes, we have a question. Is the stream being recorded? Yes, it is, and I will upload it on YouTube just like Christoph did. Right, so moving on to crime. So whenever we characterize cybercrime, we use the same principles that are taken from physical crime. And physical crime is usually characterized by three things: means, motives, and opportunity. So if you watch crime shows, you would kind of know what I'm talking about. So means is actually, let's start with motives. So motives are, well, basically the psychology of the attacker, why this person is even, motivated to attack your organization. So if it's revenge based, then we will see a very, very different kind of attack vector than if it's just a person who is testing out their new hacking skills, let's say, right? So in that regard, motives are always very, very important when we want to characterize what kind of threats an organization can face. Then we talk about means. So means are the capabilities of the attackers, what kind of resources the attacker has. And that also, the more means an attacker has, the more, well, the severe the attack will be, let's just say that. So when we talk about SQL injection attack, it's a low-hanging attack. It's a really, really easy attack to carry out. So you know that the attackers won't really need a lot of resources. And if they don't need a lot of resources and your web application is available online, then a large population of attackers can do this. Versus if we talk about nation states who will have a lot of resources, and their motives, if it's espionage or something like that, then we'll see very, very targeted kind of attacks. And then you would really need controls that are specifically meant for those kind of attacks. And finally, we talk about opportunity, and that is, this is technological stuff, right? So if your web application has vulnerabilities, it's providing an opportunity to the attackers to actually exploit it. So as developers, where do we come in? Our first goal should be to reduce the opportunities for the attackers. The less vulnerabilities our web application has, the less opportunity they will have to actually exploit us. Then the means. So if we increase the effort level for the attackers, then a lot of script kiddies and people who don't really have a lot of resources will not be able to attack us anymore. So in that regard, we can increase the means by putting in controls, making sure that low-hanging fruit attacks don't exist. And let's say we have antiviruses and everything is up to date and so on, right? The typical stuff. But one thing that we cannot control is the motives part. So the motives as in what are the intentions of the attackers. But one thing that we can do is characterize the intentions of the attackers, making sure that we know what are the reasons why an attacker would hack us, and based on that we develop our controls, right? So in all three domains there is something that we can do as developers, and when we develop our security strategies or making sure that the systems are secure, we can think from these three perspectives. So talking about attacker intent for SQL injection attack, so depending on the means and the capabilities that the attacker has, there are three, high-level kind of intentions that attackers can have. So the first one is really about stealing stuff, right? So if they want to extract data, if they want to, so the stuff that we saw with union-based attacks and tautology-based attacks, that usually falls under here. So if they can steal stuff or they want to bypass authentication. Now, the thing is, you don't necessarily need to add or modify data in order to bypass authentication. If you remember from the lecture, if we can access the login credentials from the account, you don't really need to add anything. You can just reuse the credentials and bypass authentication altogether. Then we have attackers who are mostly on the exploratory side. They're trying to, usually this is the first step in an attack, which is trying to figure out if the website is even vulnerable. So this is where identifying injectable parameters comes in. So they will be trying to inject, code and malicious stuff in all of the various parameters that they can control, where they can put input, and then they will be seeing if something weird happens, and then they'll take it from there. Then the other thing is performing database fingerprinting. So if you remember from the lecture, we discussed that sometimes the errors are so detailed that they give away information about the type of database you're using, basically the exact version of the database you're using, which function the error was in, which line number it was in, right? So the errors can be quite detailed. That's one way to do database fingerprinting, but then the other way is to write different syntaxes for different types of databases. So you know that for Oracle, the syntax is a little bit different compared to MySQL or Postgres, for example. So in that sense, if you enter different types of syntaxes, you will see that basically whether the attack happens or it doesn't happen. And then you can also fingerprint the database. And the reason why attackers want to fingerprint operating system or underlying systems is so that they can, figure out if there already exists a vulnerability in that system. If it does, then, by all means, you can simply just exploit that known vulnerability. You wouldn't have to find a new vulnerability anymore, right? So in that regard, you cannot really stop the attackers from fingerprinting your system, but you can make sure that you have updated systems so that there are less number of well-known vulnerabilities out there. Then another part of exploration is also determining the database schema. So this is something that you are already doing in assignment 3, which is trying out SQL injection, figuring out all the tables or the columns, all the constraints on the schema. And once an attacker has reverse engineered the entire database schema, then all they need to do is figure out which tables and which columns they're interested in, what kind of data they're interested in, and they can do the attack and they can steal any information they want. So these are the 3 intentions for exploratory purposes, let's say. But then we also have attackers who have more nasty or more advanced intentions, and they fall under the remote commands. So sometimes it is possible. I don't know if it's possible with the web shop. I would advise you not to try because then the web shop will become unavailable for your fellow students and you won't be able to complete the assignment. But sometimes it is possible that you give a really, really big payload to the web application and it creates some sort of stack overflow at the back end, and then you can get access to the memory. You can cause a denial of service because of this. There are many, many variations of denial of service attacks. You would have probably seen some of the examples in the lecture when on Socrative, when they were all talking about the different types of threats. Some people talk about different types of denial of service attacks, but that is possible. And the point is the server will not be able to access legitimate users' queries because it's just busy responding to what you asked it to do. And the most advanced version is also, if you can have access to the memory, you can probably get access to credentials, or you can create some sort of a reverse shell where then you can execute commands on the server, and you can also perform privilege escalation. So the kind of user that's running the system, if that user doesn't have a lot of resources, you can, with SQL injection, do privilege escalation so that the user has root access, and then you can do whatever you want. The thing to remember, though, is SQL injection is not the only attack that's meant to do that. There are, of course, more advanced versions, so you can also do that. But be aware that there can be many, many different intentions of doing an SQL injection, not just stealing data, but also exploring or doing other kind of commands. Okay, so in the lecture, okay, so there's a comment about the star. Yes, okay, I didn't know that. I'll change that. I'll change that when I upload the slides. Okay, so in the lecture, we talked about these 6 major threats to database security. Well, you'll see that most of these are related to web applications, but web applications that have a database component at the end. When we talked about weak authentication, we talked about 3 different things. So having either no credential, no uh, authentication service at all, or having default username passwords. The second one was using weak authentication, so using weak passwords that are already available in some password lists, so that will be really easy to crack. Or the third one is, even if you're using really strong passwords, if you write them down in a place where other people can see them, then that's a problem. Right. Then the second one was excessive database privileges. So remember in the previous slide, it just talked about if a user who, so the user that's running the database instance has some privileges on the system. In my case, the web shop that you have for the assignment is basically running on a Linux server on a user that doesn't have any privileges at all. The user doesn't have any privileges to write on the disk or delete anything from the disk. The user can only read stuff, right? So in that sense, it doesn't have a lot of privileges. And even if you're able to hack into that system, you will see that well, there's not much you can do unless you do privilege escalation. So in that sense, database assigning appropriate database privileges to users, or keeping in context the kind of threats that you can face is important. Then we have inadvertent insider threats. So this is something that I want to expand on later, but it mainly means, well, right now, in the current threat landscape, we don't really see insider attacks as in espionage. Maybe that happens, but it's, it comes at the nation state level. So it's at a very, very big level, and they are pretty stealthy. So we won't really know that. But inadvertent insider threats are users, employees who are not aware of the security practices, and then they do something that compromises the security of the organization as a whole. Then we have DB injection attacks. So we talked about SQL injection, but we also saw that no SQL is not any better. And then we talked about unmanaged sensitive data. So either don't store sensitive data of users like credit card information or DNA information, I don't know. Or if you have to store it, then store it encrypted or in a secure way so that even if it's compromised, well, the data itself is not compromised. And finally, we saw vulnerable databases. So this is where the underlying vulnerabilities in the databases comes into play. If there's an unpatched vulnerability in any of the components in the whole web application infrastructure, then it's possible that the attackers might make their way from the web application to the server, to the database, and whatever, right? So it quickly becomes really, really complicated because web applications have a lot of moving parts. So you have to make sure each one of them is secure enough. Okay, so now let's talk about inadvertent insider threats. Okay, if you have any questions about the lecture, you can just post them and I will see the comments and answer them as soon as they're right, okay? Okay, so humans are the weakest link. So this is something that I mentioned in the lecture, and it can be perceived in a negative connotation, but I want to clarify that here. Yeah, because it's not just a simple thing that humans are stupid, so you should not give them any control. The thing is, human intelligence is really, really important, and we know that systems, no matter how intelligent they are, they cannot compete with human intelligence, right? So human intelligence is important. The issue comes in two flavors. The first thing is the users are unaware of the security principles. They don't know any better. So that would be the case of, let's say, older generation or people who are not well versed with technology today. In that sense, well, employee awareness or awareness campaigns in general would be the way to go. You give knowledge to your employees, making sure that they know what to do and what not to do. What should they do in case they make a mistake, or what should they do in case they see something that is just strange, right? So this is the case of social engineering attempts where you see phishing emails that are very specific to your use case, and then they are sometimes very, very convincing. So employee awareness can help those users or employees who are just not well versed with the technology. Then the second type that I think exists is, well, users who are well versed in technology, but because the systems are designed so poorly, they don't know what to do with it. And this is an example of a system that's really, really complicated to work through, and then they have a lot of different options, and then they don't read through all the options, and they make some configuration which is actually not good, and the attackers can exploit that. So when we talk about humans being the weakest link, we talk about where you should put the most resources in, while making sure that the security is upheld. Yeah. And so we also saw that even if you have the latest technology in place, we talked about updating your systems every time. Well, if you update your systems, then you immediately have to do employee awareness. And sometimes, well, the budget doesn't match anymore. So what to do about that? So it's just a good thing to keep in mind that technology and employee awareness goes hand in hand. You can have the latest technology, but if your employees don't know how to use the system properly, then, well, it can be exploited. But on the other hand, if your technology is not as up to date, but your employees are pretty up to date, in that sense, the attackers wouldn't really need to come through social engineering. They can just attack the technology itself. So it's a balance. Okay, then we talked about no SQL injection attacks. We said that, well, if you don't have any SQL, you would not be vulnerable to SQL injection attacks. Yes, you won't be vulnerable to SQL injection attacks, but you would be vulnerable to no SQL injection attacks, where we're exploiting the syntax of no SQL. So this is an example that I took from this blog here, which shows how no SQL injection works. Mainly, this is a login routine where you can, well, a user is expected to enter username and a hashed password. So basically, the user will enter a password which will get hashed, and then it will get compared with this variable here. And if, let's say, the user enters username as admin and password as this, then GTE in MongoDB is, greater than equal to sign. So it's a special, it has a special meaning. And once this input gets plugged in here, we see username admin and hash password of this. So what gets executed at the end of the day is, well, find in the users, find a username that has a username of admin, and which has a hashed password of a non-empty string. Meaning, if there exists a username of admin and some password, of course the string won't be empty, and that's the one that will be returned. So in this case, you don't even need to know the length of the password or anything. If you have a username admin, then you will be logged in essentially. So no SQL injection attacks also exist. Right. Okay. Right. Now, let's talk about some security best practices. So we discussed many of them on this, many of those on the slides. Some of them are, of course, simpler to understand than others. One thing that is an ongoing, well, research field right now is homomorphic encryption, so that we can have, well, one of the applications would be to have entire databases that are fully encrypted. The queries that are coming in are also encrypted. And the operations are being done on encrypted stuff, and there's results, well, the correct results are generated. So in that sense, the database never even sees the unencrypted data. And in that sense, well, of course, we have a very low risk of compromise. So here on the slide, I have a very simple example of homomorphic encryption. Of course, it's an advanced topic and it's not included in the exam, but it's still interesting to know if you are interested in database security, because this really targets what is at the core of database security, right? Making sure your data is never compromised. So let's suppose you have, well, this side is you as a user, and this side is a party that you don't trust, but the party that has resources. So we can think of this as the database, let's say, or some sort of query engine, and this is us with our plain text data. So suppose that we have two numbers, 5 and 10, and we want to add them, but for some reason we don't have the resources to add these numbers, right? And we need to use this external party to well, add these numbers for us. So what we will do is we'll encrypt these numbers using a secret key that only we know. In this case, let's say the key is, well, a factor of 2. So we multiply this, and then this plain text becomes the ciphertext, which is 10 and 20, right? So this is the ciphertext that we give to the external party. Now, this external party will just, do the operation as we requested it. It will just simply add these numbers. That would turn it into 30, and that's what's returned back to the user. Now, the user knows that this data that's returned back is actually ciphertext, so we need to decrypt it. And decryption is the opposite of encryption, so the key that we used here, we can just reverse it. So instead of multiplying, we just divide the number, and we get the plain text, which is actually the correct value, right? So homomorphic encryption is you can do operations on ciphertext which still have meaning. But at the same time, the party that you don't trust is not able to see the plain text. So you can use this principle to build databases that store encrypted stuff. The queries come in as encrypted stuff, and then the operations are done on the encrypted stuff, and then the results that are returned back still make sense in plain text. So we have a question about, doesn't encrypting the entire database have a huge performance impact? Yes, it does. And that is one of the reasons why homomorphic encryption is not, well, widely implemented. Of course, there is a really, really big performance impact on, and of course, the memory utilization as well, because ciphertexts are usually longer or bigger than the plain text. So the operations that you would need on smaller text, you would have to do them on bigger text, and then they are also slow and so on. So there are a lot of problems, and that's why this is an active area of research. You're right. Okay, now I have some questions for you. So in the lecture, we discussed this, but I want to make sure that you understand. So what is the benefit of logging everything that happens on the system? How does that relate to database security? Yes, very good. So you can, well, this is mainly meant for auditing purposes, meaning once the attack has happened, you try to figure out why it happened, which vulnerability was exploited, where the attack actually happened, and what things were stolen or damaged or so on. It doesn't help to prevent the attacks. Well, it helps to prevent future attacks, but the attack that has already happened, it helps to make sure that it doesn't happen again. Okay, one of the comments was removing tampered information by looking at the log. Yes, it's a very specific use case, but yes, it can be done. If you see that the attackers changed something in your database, then you can simply just remove those logs. So in that case, if they try to add, let's suppose, a backdoor, you know where the backdoor is. And actually, the problem of finding backdoors is really, really important and difficult. So yes, that is also something that can be done. Okay. Then, all right. Okay. So what is the benefit of having the latest software? This is the second question that I have for you. How does that help prevent or reduce database attacks? Yes, very nice. So having the latest software helps you staying up to date with security features. Old mechanisms are more vulnerable to attacks. Exactly. So these are two common questions that I have had previous students ask, and well, now you know the answers. All right. Then we also discussed disabling default error reporting. So there is actually a type of SQL injection attack, which is called error-based SQL injection attack, that mainly feeds from the errors that the web applications generate. So on a slide here, you see an error that was generated when there was a syntax problem in the query that, well, a person entered. And it tells you, well, what kind of database you're using, right? So this is a MySQL database. And we can also kind of see which method it was or which line the error was, and also maybe the data type. So this is still, I would say, a somewhat better error messages. There are some error messages that are so detailed because they just print the entire SQL query itself, saying, oh, you have an error in this particular column name, and printing out the whole query. So if that happens, then the attackers know exactly which data type to use, well, how to formulate the query, and so on, right? So this is very, very well, exploratory version of the attack. But if you disable the default error reporting, then you wouldn't see these kind of SQL injection attacks, at least. So there is one thing that I want to clarify about the previous, so having the latest software. So in practice, you would see, well, if you have experience with interning at some software companies, you would see that industry doesn't always use the latest versions of software. And that's because they have a lot of dependencies, and then the dependencies tend to break if you update even one version of the component, right? And so there, well, saying, you should always have the latest software, it's a very, very idealistic statement to have. It's a good aim, but it's not always doable. So in that case, well, the organization or the company should really be aware of the threats or the risk that it is exposed to. There's nothing more that can be done in that regard. Okay. Then SQL injection. So we already discussed what an SQL injection attack is. It's where if you can execute commands, SQL statements on a database server that you have no control over, well, then that is an SQL injection attack. There are varying definitions of what constitutes as an SQL injection and what doesn't. So for example, there is an attack called directory traversal attack, where in the URL, you can jump back the directories. It's okay if you don't know about it, but for those who know about this attack, sometimes that's also referred to as an injection attack, but in my opinion, it's really not, because injection is when you're executing code, when you can inject code that actually gets interpreted. But in the case of directory traversal, what you're basically doing is exploring the different directory paths. So in that sense, you're not really executing code, if you know what I mean. So, well, SQL injection is one of the low-hanging fruits. So it's a very simple attack to exploit, doesn't take a lot of resources. So of course, there is a huge attack surface for this, but it's also relatively easy to fix. So it's still surprising that these attacks still exist. But one of the major debates that database people have with web developers is who is exactly responsible for SQL injection attack? Well, the answer you see already on the slide, and we also discussed this in the recorded lecture. Well, basically, the problem of SQL injection isn't created by one party alone. It's two parties that are responsible for this. The fact that there is something valuable in a data store creates the incentive to hack it or try to break into it, right? It's, basic human psychology. So in that sense, the rewards are basically generated by the schema designers who decide to store data unencrypted or store sensitive information or, have multiple copies of the data and so on. The higher the rewards, the bigger chances that it will actually get exploited at some point. But the opportunity, which we talked about, right? Means, motives, and opportunity, we talked about, well, opportunity is created by the web application developers when they choose to implement, query stuff in an insecure way. So again, the responsibility lies on both ends. You should never store information that is, sensitive, that would create the incentive for somebody to hack into the systems. But of course, when we look at Facebook or Gmail or Twitter, they do have a lot of information that people would really like to get their hands on, and that's their entire business model. So in that sense, if they are storing the stuff, they should protect it better. And they should protect it better by making sure that the web application developers don't make any mistakes. Okay, now we talk about something that is important. How do you test if a web application is actually vulnerable to SQL injection attack? So let's suppose that you have a system, a web application that, well, works perfectly. So here I would actually like to go here. All right. So, I mean, if I enter something here, which is not, which doesn't contain a special character, we are actually seeing valid results, right? So the web application is working as intended. But all of a sudden, if I add something that is a special character, and I receive a 500 error, internal server error, then that indicates that something went wrong with how the query was being processed, right? So there can be arguments as to why, well, this error happens. Perhaps somebody plugged out the database server, or the connection broke, or there was a lot of let's say traffic on the server, and that's why I couldn't respond, and so on, right? So there can be many reasons why an error like this can occur. But if this error happens when you specifically enter a special character, but otherwise it works fine, then we know that there's something that can be exploited. So this is one of the most classic ways of, oops. So this is one of the most classic ways of testing whether the application is vulnerable or not. Many people I know, when they are asked to do a penetration testing on a web server, the first thing they do is they go and they try to put single quotes or double quotes in all of the input boxes where they can enter text, basically, just to see what happens. However, if you don't see an error, that does not indicate that there is no problem, because it's just possible that the developers are not showing the error to the users. They're doing some sort of smart error reporting. But there are also ways to do SQL injection where you exploit the fact that there is no output. So this is the the different variations of SQL injection. We covered the first three. We talked about tautology-based attacks, where the goal really is to have a Boolean as the Boolean to make sure that the attack happens. We have a comment asking if it's possible to get the source code of the website. Actually, I can share the pseudocode. I don't want to share the full source code because, well, for next year, then I'll have to re-implement it in a different way, which is going to be difficult. But yes, I'll see what I can do. Okay, so yeah, we talked about tautology based. So, well, in this case, what we really want to generate is a tautology, a condition, a logical condition that always returns true. So it could be, any condition, 9 equals 9 or 1 equals 1. This is, 1 equals 1 is a classic example that's used in tutorials over the web. And then, of course, so commenting out is not really part of the type of SQL injection attack, but this part, or 1 equals 1, is what makes it a tautology-based attack. Now, there is actually, would I say it's a bug in the web shop? Okay, I don't know. And I don't know if any of you have found this out, but I just found it out recently that there's actually a bug. So you don't even have to enter all of this special code to see everything that exists. You can simply just enter, a wildcard character and you would still see everything. Because percentage sign is, a wildcard that's used in MySQL that says a character that enters 0 or more times, and well, basically all of these characters either enter, 1 or many times. So that's why you can also have this. Now, would you call this an SQL injection attack? Yes, because this is a special character and it's not interpreted as a percentage sign as in a single character, but it's interpreted as its special meaning in the code, which is a wild character. So this is also, an SQL injection. All right, so in tautology-based attack, we have control over only the condition. So we can only mold the condition to make it a tautology. Yes, so hash sign does commenting out. We will discuss, there are different variations of how you can comment out stuff in the query in the next slide. Okay, so the second type of attack that we looked at was a union-based SQL injection, where the goal was to have control over which table was queried and which columns were queried. So this is something typical that you will see if you want to extract information from a table that is not currently being queried. So an example with that would be, union select username password from oops. So if you've done the assignment, you would know that one of the table names is customer. So what we're doing is we're putting the union keyword, and then we're adding a subquery that will combine the results of the previous query with the next query. Now, there is something that's important that I want to discuss, and that is what can you query for? Now, in some databases, in some database engines, let me just say that, the standards are really followed. So in that sense, the data type of whatever is being queried here needs to match exactly the data type of what the original query had. So in this case, if you see item name, we know that it's probably a string, right? It's a varchar. But item price, that might be a float or an integer. So an integer must only be compatible with an integer, right? So in databases that are following this standard, this particular query will not work, because you will have a data type incompatibility or mismatch between the item price, which is of type integer, and this query, which is of type varchar. So the safest way to actually exploit in this scenario would be to simply write null, because null is something that is actually compatible with all the data types, right? So if you do that, then the attack would actually work. And this is okay. Let's discuss that actually later. Okay, we have some comments. Yeah, what was it? The DSF, this is nothing. It's just a query that I'm entering. So if I enter an empty thing in the backend on the server side, there's a like query with a percentage sign already encoded. So basically that means just get everything. So I see the results of the first query appended with the results of the second query. And the reason why I entered DSF is because I know that there is no such item which is named this, and that's why I won't see the results of the first query. So this is just to make sure that the output is not, well, messy. Okay. So yeah, so this is important, right? Union-based query returns compatible records, and sometimes as an attacker, you will have to figure out what the data type is, and sometimes you wouldn't because the database engine wouldn't be following the standards. Right, then we talked about piggybacked queries. So this is something that the web shop is actually not vulnerable to, at least not in my knowledge. But if you have been able to exploit a piggybacked query, let me know. I have to change the code. So in that case, so piggybacked query is when you really have control over the full query. So if we were to say that the web shop was vulnerable, what the piggyback query would look like is, well, we finish this query, right? And then we just add anything we want. So drop, table, customer, and yeah, right? So we are basically adding another independent query on its own. Well, this is the, well, yeah, I've tried it. I don't think this works, but if it works, then we're probably in trouble. Okay, then we have error-based SQL injection. So error-based SQL injection is where, well, an attacker intentionally writes something that will cause an SQL injection error, well, sorry, an SQL error, a syntax error. And the hope is to return something informational from the error. So the error that is reported, maybe it contains some meaningful information that will help me craft my attack better. Then in the previous slide, we discussed what happens if there is no error message. Are you safe from SQL injection? Well, not necessarily. There are attacks that are based on inference, meaning if you're not getting the exact output, the way the web application behaves, you can infer something about whether your query worked or not. And that's called a blind SQL injection attack. There are two variations of this. It can be Boolean or it can be time-based. So I have one example that is meant, well, that's an example of a time-based attack because it's more interesting to see. But I would like to say that there are, probably many other type of attacks. And actually, if you read this article in the additional material, I think it should be in the slides that were uploaded on Brightspace as well. This is a very nice paper that summarizes SQL injection attacks, attacker intention, various types of attacks that exist, and how to protect against them. So if you're interested in knowing more about this, do read this, but it's not part of the exam, so don't worry about that. Okay, so coming back to blind SQL injection. Okay, we have a question first. Okay, so I said that the union SQL injection is limited by the number of columns. Could you give an example of how that works? Sure. So this is an instance of, well, let's suppose I don't know what query is being executed at the backend, right? I'm an attacker and I don't know what query the server or web application constructs. So I will have to, well, experiment with different number of columns to see what I can get out. So select 1, 2 from dual. So this is an example that I used in the lecture. Let's suppose that, well, we start with one number of columns. We know that there are 2 columns, but, just for the sake of an example, let's say I do this. Now I receive an error. Now this 500 error could mean that the query that I have constructed has a syntax error, right? Maybe I misspelled union or something like that. Or it could simply mean that there is a column mismatch happening. So this is really where then the attacker would have to hit and try, make sure that you're eliminating all the possible incorrect options. So, okay, first I tried out with one number of column, then I try out with two number of columns, what happens? And if I see the output, it means that I know that in the backend, in the query that the web application is generating, it's querying for only two columns. If I try to add more, I will again receive an error. So now I know that I can only search for two columns at a time. Of course, whichever table I want to query. So I can query from, well, the dual table is just for testing purposes, but I can query the customer table and then I can access username and password. But let's suppose there was additional information in that table, like the user status or when the user registered, then I would have to do multiple queries so that I can get access to those columns as well. I cannot query for all those columns in one go. Hope that answers the question. Okay. So we're talking about blind SQL injection. So this is an example of a blind SQL injection, which is a time-based attack. And this is where the idea of the behavior of the web application comes in. We look at how the web application behaves in general. So an example of this is in the login page. So let's suppose, well, obviously I don't know the username and password, let's suppose, right? So we get an incorrect username and password. And if I try, so the thing is, so it's tricky, right? This is not a very good example, but I will demonstrate the time-based error in just a minute. The idea is if I were to do an SQL injection here by saying, union select one from customer and I comment the rest of the stuff out, I will actually get a positive answer because it's, probably creating a true condition somewhere. But I cannot see which username it was, right? I want to see the username. Let's say I want to access all the usernames from customers. And I don't see that because that's not what is, the output that was generated by the SQL table is somehow filtered in the web application. So all I see is, a modified version of the output. So if I want to, then, I'm not receiving the output that I want, then I can do an inference-based, a time-based blind SQL injection attack where I say, first let's check if the query even executes, right? What happens if the condition is true? So if I enter sleep 3, hold on. So you have, some random username and then union select sleep. I hope you can see this, right? So what would happen is the first part of the query will get executed and then union second part of the query will get executed. And because we have this hash sign, the password field and the rest of the query will not get interpreted, right? So if this executes, then we will see the answer after exactly 3 seconds, right? So this is how a blind SQL injection works. It didn't take long to respond. It just took 3 seconds to respond. So if I change sleep to 1, then it will give a response back after 1 second. And if I increase the sleep time, then I will know that it will respond after that amount of time. This is one way you can do a denial of service attack. If you do a sleep for, a really big number and you have a lot of open connections, then the database will probably not respond in time. We'll have to see how that works. But we can use this information, this trick, to figure out whether a certain username exists in the table or not. Let me see. So an example of this is written here. So let's say I want to check whether, Fluffy Bunny is a username in the table or not, or, and a typical case would be checking if admin is a username or not. So I will just say union sleep3 from users or customers in our case, where username is this. If the response is received back after 3 seconds, it means that this username exists. And if it doesn't, then we know that this username doesn't exist. So let me do a quick demo and then we move on. So select sleep3 from customer where username is admin. Let's see what happens. So it just gave me an incorrect response. But we know that Fluffy Bunny, right? This is probably how I wrote it. That exists. And so the answer will be received back after 3 seconds. So I know that this is a username that exists. So you can use these tricks to sort of infer what is in the table and what isn't. We have some questions. So we have a question of why does the union work, and if we get rid of this, why this doesn't work? The reason why it doesn't work is because I have put in some controls in the web application to avoid piggybacked attacks. Yeah, so that's why it doesn't work. But in principle, it should. And actually, there is a different reason why it might not work. So when we do a union, what we're doing is we're concatenating the results of one query with the other query. So if the first query was used in the, let's say, output, if it was rendered in the user interface, then now, along with the first one, I'm also getting the second one to be displayed on the same user interface. But once I do a semicolon and I start a new query, then, well, the results will be returned by the database, but how will they be displayed? That's a question. So when would you need sleep? Well, you can need sleep for the case where you're trying to do batch inserts, let's suppose. You have a lot of data and you want to insert that. But at some point, the connection is too slow or it starts to choke the database. So then you probably would need to add a sleep somewhere so that, it's a little bit slower. That could be one use case. There can be others. That's the only one I can think of right now. So okay, so this is an interesting question. Why do we use select username password? Why can't we do a select asterisk? You can do a select asterisk if you know that the number of columns in the table match exactly the number of columns in the query. So here, the query in the backend is actually returning only one column, and that is the user type, right? So if I want to, right? So if I want to get access to, let's suppose, a table that has 3 columns, and I do select asterisk from that other column, then we'll have a column mismatch error. But if it's from a table that only has 1 column, like dual, then it will actually work. Okay, let's move on. Okay, so this blind SQL, of course, it's extra, but it's fun to see that you don't necessarily need the exact output to, well, steal stuff. You can do blind SQL injection even when the error reporting is done slightly smartly. So that, I mean, that tells you how difficult it is to make sure that your application is completely secure from SQL injection attack. Of course, one way is to implement controls properly, But in case you mess up, then, all of these variations pop up suddenly. Okay, so this is where some of the different variations of SQL injection comes in, what works in what scenario and what doesn't. And this is where the attackers really need to do hit and trial to see what works and what doesn't. So the first one I already discussed with you, database engines that conform to standards. Now, the one that we are using in the web shop is MySQL, which is using InnoDB, which is known to follow standards, but for some reason, if I do a select 1, 2 from dual, it works, even though there is a type mismatch, right? I have tried to figure out why it works. It just seems like the engine doesn't care. But let's suppose if you were to do it in Oracle, maybe, or Oracle sometimes is more stringent with these things, then you will have a type mismatch error. And if you're not seeing the exact type of error that occurs, you might think it's a column mismatch error, but actually it's a data type mismatch error. So safe thing would be to just do, null from some table, and then trying to figure out how many columns there are, and then do move step by step. Then the second thing is which data type it is also will enforce what kind of syntax we can use. So we are so far using a hash sign for commenting out the rest of the query. You can also use a dash dash and then space. This actually works in MySQL. Right, so this, okay, I need to close the quote. This works, but if I do a dash dash and then space, this should also work. But depending on different databases that are being used, the syntax might be different. And where the syntax is the biggest problem is the sys tables. So in the assignment, you've been asked to figure out which is the table that contains metadata information about all the other tables and columns and constraints and whatnot that exists in the schema. In Oracle, you have a table that's called all tables that has that information. In MySQL, it's called information schema. So, well, you have to figure out which kind of database it is to figure out which kind of syntax you can use to exploit the SQL injection. Then we have evasion. Evasion is a very, very important problem in security in general. If you as defenders try to put some controls, the attackers always try to bypass that in one way or another. Now, one thing that usually people do, so let's suppose we have input sanitization in place, and we say that all special characters are not allowed, which means single quotes, hash signs, dash dash signs, they are all they are to be ignored. So this won't work, but the attacker can then encode the same character in a different, encoding in a different format, and the attack would still work. So a single quote can be converted into percentage 27. So 27, this is the ASCII version or the ASCII encoding of this sign. And it is always followed by a percentage sign. And this is, so this encoding is usually done in URLs if you enter a special character that is not typically part of a URL. So they have to encode it to make sure that it doesn't mean anything special. So this goes to tell you that even if you do an input sanitization and you remove all the special characters, well, this is one encoding where it might not work. And there can be, of course, this is not the only one. This is an ASCII encoding, but there could be, other versions. And so the game always continues. So you always have to think about the worst case scenario that can happen. Then, so then we have an important thing, which is the database user privileges. So I already discussed some slides ago that the user that is currently running the web shop, right? So think of it like this. I have a script that's implemented in Python that opens a connection or opens a schema, a connection to the database. And that user exists in the database, right? So I have a user called, okay, I shouldn't tell you that, but let's suppose we have a user sample, right? So the user is called sample. that is in the database and that has minimum privileges, meaning the user can only select stuff, not insert, update, delete, drop. So any of the data description languages the user cannot do well function. Yeah, the user cannot execute functions. Now that is the user that I have opened a connection with in the web shop. So if you try to do any special commands in the using the SQL injection, it won't work, not because my web application is protecting against it. It's basically because the database doesn't allow those functions from that user. So you see that there can be access control at multiple levels. Now, currently in my server implementation of the web application, the web shop, any special commands that you input are filtered out basically. And there's some basic filtering that I'm doing, but the access control part I have assigned to the database itself. So the database handles whether this kind of query can be executed or not. So if it's something that deletes stuff, then the database will say it's not allowed, and you will see an error. Hope that clarifies some stuff. So one of the things that you can do to actually prevent SQL injection or the severity of SQL injection is making sure that you don't run your database on a root user, which is something that people do, and I will never understand why they do it. But don't run your script so don't run the server as a root user, and don't log into the database as a root user. Just never use root unless you really have to, which is, never probably. Anyway, okay. This brings us to the last part of the lecture, which is SQL injection mitigation, which was actually the main reason why we are discussing all of this. So we saw that the reason why SQL injection happens is because the way the web application developers create the query mixes up code and data. So in a normal situation, the red stuff would be interpreted as the code and the green stuff would be the data. But if the user enters a special character or a special, characters that mean something in the syntax of SQL, then they are actually interpreted as this. So the dividers between where the user input ends and where code starts is, gone, because the so remember, why this happens is because the web application is the one that's creating the query, is constructing the query, and the database parser is the one, or database engine is the one that's executing the query. So when the query is constructed, this distinction between code and data, or user input and code, is lost because of the simple concatenation, and the database server is then the database server doesn't know what is code and what is data anymore, and we have the attack. So the simplest way to avoid, SQL injection, or to really remove SQL injection, is to put some indicators where the data starts and where the data ends. That's important. That's, in a nutshell, how you can avoid SQL injection attacks. Yeah, so we already discussed this. So whose responsibility is it to implement the 3 techniques that we discussed in the lecture? When we talk about input sanitization, that is, you have input characters that are illegal, you just remove them from the user input. This is that you can do at the web application part. When you're implementing, when you're getting the user input and you're right before you plug it into the query, get rid of all the special characters. So it's purely the web application developer's responsibility. Then escaping the input. So this is where, database engines or query parsers have this control sometimes, and sometimes they don't, right? So it truly depends on what kind of database you're using and how advanced it is to protect itself against malicious code. So even then, you should still do the escaping. Just to be safe, you should do the escaping on the web application part, even if the database is doing it at its own part. At least, you make sure that nothing can go wrong there. And then finally, prepared statements, they are something that you have to implement on the developer side. So you see that the responsibility is, to avoid SQL injection mostly lies on the web application developers end, how they create the query, how they make sure that the user input doesn't contain anything funny is truly the developer's responsibility. Okay, then we talk about where you can use certain mitigation techniques and where you cannot. So input sanitization, we saw that you would need some sort of pattern matching technique to get rid of all special characters. So let's suppose I say I have a phone number, then I know that alphabetic characters will never be part of the phone numbers, right? So I can just make a regular expression or a simple pattern that says all alphabetic characters from this user input needs to be removed. And in the end, what I'll be left with are uh, probably plus sign and then numbers, right? So the format there is quite clear. But what happens when you have a blog post or a comment? You can have any sort of input, right? And all of those punctuations in the English language, they mean something, well, they add something in the semantics. Let's suppose I'm adding a blog post where I quote somebody else, then I will enclose it in double quotes. But if I were using input sanitization, then those double quotes will be removed and the semantics of my post won't make sense anymore. So in that sense, if you don't have any limit on input characters, or if there's an encoding happening, right? So single quotes are turned into percentage 27 or something like that, then input sanitization will fail badly. And of course, the problem with input sanitization is that it's messing up with the semantics of user input. So I'm sure that you wouldn't appreciate if you were, leaving a comment somewhere and then the server kept removing all punctuations and special characters, right? So it messes with the semantics. The second one is escaping user input. Now, the reason why I put it here, so the goal is to neutralize the effect of special characters. If there is a special character like a single quote, we put a backslash and we tell the query, the database query parser not to process this. However, as we looked at the second order SQL injection attack, it is possible that it simply just delays the effect. It stores the data safely, but later on, when it's queried from the table, that's when the attack happens. So escaping user input can also go wrong pretty quickly if you're not aware of what you're doing or what can be the circumstances of taking certain design actions. So a simple way to get rid of this problem or second order SQL injection is to make sure that whenever you're dealing with user data, whether it's coming from the user itself or from a data store that contains past user inputs, you make sure that you escape it. Well, whether you want to sanitize it or not, that's your choice, but make sure that you escape it because you never know what the data might contain, right? And then the third one is prepared statements. So prepared statements are query templates or query plans that you already make. They are pre-processed, and then the user input only just gets plugged in, and the user input is not processed. So basically, the effect of special characters, there is no effect, mainly because it's never interpreted as part of the query. So prepared statements are, if you think about it, truly the solution that put dividers between what is user input and what is code, right? So this is the solution, the ultimate solution to avoid SQL injection attacks. However, the story isn't that cool either because there are cases where you cannot use prepared statements. If you're using dynamic queries or you're using object relational models, mapping, sorry. So for example, in Java, there's a framework called Hibernate. If that is what you're using, then because you don't have variables beforehand to bind with, you cannot make a query plan beforehand, right? So in that sense, you won't be able to use prepared statements anymore. And then you would really have to fall back on a combination of escaping user input, input sanitization, or some other methods. So the summary of this slide is not, well, there's no one best solution that works in all of the cases. You really have to see what is the context, what's the importance of user input, where can it be used, and then you try to implement one of the mitigation methods. Now, this is not an exhaustive list, I have to say that. There are other methods that are more advanced, that are based on detection strategies and whatnot. So these are the basic strategies that you can implement, but then you can use these to build up more advanced systems. And some of those are actually explained in this article here. So you can, if you're interested, you can read about that. But really, what it comes down to is whenever you can use prepared statements, you should use prepared statements, because they not only optimize the query processing time, they also secure you from SQL injection attacks. So we have a question, is prepared statement the same as a parameterized query? I think so. I think they are the same. So basically a prepared statement is, let's suppose I were to say, select username and password from users where user status equals question mark, right? That's where the user input comes in. And I will just make the plan beforehand. And then later on, when the user input comes in, if I enter admin or staff or something else, then that just gets plugged into the user input and it's never really processed. So I think that's the same idea as parameterized query. Yes. There's also something called stored procedures, which is a similar concept, but that is different because in stored procedures you have, okay, so from what I understand, in stored procedures, you don't necessarily put the limitation that the user input is not plugged in. You can have multiple statements that are pre-computed so that later on, you don't have to process everything again. So stored procedures are mainly meant for optimization, I would say, but prepared statements have an additional advantage, that they protect you from special code and their side effects. Okay, so this is the end of the lecture. If you have any questions, just post them and then we'll see what to discuss next.